Welcome back to the lecture series of electronics measurement and instrumentation. In this lecture, I am going to discuss about a solid state voltmeter. So basically, the solid state voltmeter is given in this figure 4.13. It consists of a operational amplifier, diodes, and resistors, and it is a basically multi-range solid state voltmeter. Initially we see there a circuitry we have used to convert this voltmeter into a multi-range voltmeter. So basically 4.13 show the circuit of an electronic voltmeter, and the main IC is operational amplifier. The IC number is 741. So this is a direct coupled very high gain amplifier. That is basically operational amplifier is called direct coupled very high gain amplifier, and the gain of the operational amplifier can be adjusted by any suitable lower value by providing appropriate resistance between its output terminal. That is the basically process that used to adjust the gain. The ratio R2 upon R1 determine the gain, that is 101 in this case, provided by the operational amplifier. The 0.1 microfarad capacitor across 100k ohm resistance R2 is for stability under pickups. See here in this particular circuit diagram. In this diagram we using this particular circuit. That particular actually circuit is used as a DC blocking. So if it is a DC used for the DC blocking, that particular DC blocking circuit is here. They written that they provide stability under step pickups. So it means in the case of the noise or the noise that consider noise is attack at the input terminal, so it will not pick up due to this 1 microfarad capacitor, and the resistance that is called the R2, its value is around 100k, and that is the basically resistance combination that they have discussed. This that is basically a potential divider bias that is already mentioned in the previous lines. The 10 IC S2 the 10 kilo ohm potentiometer is connected between these two offset null points. See this particular that is basically a type of the potentiometer. It means that because the potentiometer is nothing but a variable resistance, it is connected. It is connected between the null offset terminal with center tap connected to 5 volt supply. See here, this that is connected to it is connected to a 5 volt supply. This potentiometer is called zero set and is used for adjusting zero output. In the previous lecture, I have already explained the use of this basically potentiometer and what is the basically the offset condition. In the previous lecture, we are using emitter follower circuit. Here we use the operational amplifier. Then there we have discussed about what is the purpose of these two diodes. See, this is used for IC protection. Under normal condition, they are non-conducting, and the maximum voltage across them is 10 millivolt, sorry, not volt. If an excessive voltage, say more than 100 millivolt appear across them, then depending upon the polarity of the voltage, one of the diode conduct and protect the IC. So basically this particular circuit is used for just for a protection circuit and nothing else. So a microwave scale of 50 to 100 microampere full scale deflection can be used as an indicator. R4 is adjusted to get full. See here this R4. So see here we using a potentiometer at this terminal. That is also it is a potentiometer. So this particular basically potentiometer that used with the operational amplifier, that is used for offset adjustment, and that particular transistor R4, it is used for get null voltage, null deflection on this terminal. So if there is any offset voltage at the output of the operational amplifier, this potentiometer is adjusted to the zero. Offset is nothing but the output with the absence of input. Similarly, this potentiometer is used for null at the to provide null reading at the deflection system. So that is all about the solid state millivolt voltmeter, and that voltmeter is designed with the help of operational amplifier because its range is in a millivolt range. So very small voltage is applied at input terminal, and we know that is the operational amplifier is high gain amplifier, so it's amplify the signal and make it measurable to the emitter circuit. So that is the overall explanation of this. Then next topic is AC voltmeter using rectifier. So AC voltmeter using rectifier type instrument generally use that also use PMMC. PMMC is basically this particular instruments. This particular instruments is called PMMC. Just forget this R4 because it is the variable resistance, and consider R3 is considered RM. It means internal resistance. So if this whole two resistor combination is replaced by a resistance RM, and then this particular circuit, it's form a PMMC instruments, that is also called diurnal movement meter, or it is called permanent moving magnet coil system. So basically the diode is, you will see this particular circuit, we are using the silicon diode because its reverse current is low and forward current is high. So and this particular circuit is nothing but a bridge circuit. The bridge rectifier provide a full wave pulsating DC, so you know that it is a bridge circuit, so the output is a pulsating DC. Then we required a low pass circuit to convert it into the pure DC. But if you are not using any filter, it means we got a pulsating DC. So due to the inertia of the moving coil, the meter indicate at a steady deflection proportional to the average value of the current, because this AC is converted into the DC. The meter scale is usually calibrated to give RMS value. It means we have calibrated a meter in such a that the reading show the RMS value, not the peak value. Practical rectifier are non-linear device, particularly at low value of forward current. Hence, the meter scale is non-linear and is generally crowded at lower end of the low range voltmeter. Actually, due to the non-linearity of the diode, scale used for the measurement is also the non-linear. So if it is calibrated at high frequency, so it is the crowded at the low frequency. So if we are calibrated at the low voltages, so it is crowded at high voltages. So it means that we decide first a range of the measurement that is possible with a particular instrument. So the rectifier exhibits capacitance property when reverse bias and tend to bypass higher frequency. The meter reading may be in error by as much as 0.5%. It means this type of the device have generated 0.5% error, and that is decreased for every 1 kilohertz rise in frequency. It means at high frequency errors will remove, but at lower frequency error is high. So seen here a new diode that is also a rectifier type AC voltmeter, and we know that it is a rectifier. It means this AC signal is again converted into the DC. Then we have the measured it with the help of this RM and RCA. This particular, it is a voltmeter circuit. So we convert the AC to DC, then we apply this DC, and then we are able to measure. That already explained in this particular diagram. So that is all about this two circuit. So it means generally what we try to do, we convert this AC voltmeter, DC voltmeter to AC voltmeter. So once we want to measure the AC quantity, generally our concern is to measure only the amplitude, because generally we measure the voltage level. Frequency is also constant. Any AC signal, the frequency is constant. So what we can do, instead of using or designing a AC type of the voltmeter, we convert this AC signal into a DC signal, then we measure with the help of the DC voltmeter. That is the actual principle behind the measurement of the AC voltages and or the current. So that truth circuit is basically, in the first circuit we see how we measure a voltage, AC voltage. In the second circuit we have in this first circuit, how we so that how we measured voltages, DC voltages with low values. But in the second case, instead of the DC voltage, if we have the some AC quantity, then by converting this AC quantity to the DC quantity, we are able to measure. Only problem we have the facing is face to how to divide the scales, because the calibration of the scale create the problem only because due to the variation in the frequency. But if the frequency is constant, then we are able to measure this AC to DC. So that's why we use a DC voltmeter for the measurement of the AC voltage. That's all about the today lecture. In the next lecture, we were going to discuss about true RMS meter. Thanks for your kind attention.